Hello everyone, this is Sean from Tech Data. When we create an AI application, I think we all share a question: which model is the right model for my use case? For right model, it doesn't mean the bigger model. Since the bigger model doesn't guarantee a better performance, bigger model also mean more expensive to interface and to host. So today, I want to show you how to use watsonx governance to evaluate different foundation models on your use case. For doing so, we can easily identify the right model, which means cheaper, faster, and better. To do the evaluation, I create two testing. The first one, we will do the sentiment analysis on customer review on different foundation models. Um, and compare the performance. The second testing, we will do more complex, which is summarize the news to a high level summary and on the same different models to see the performance. All right, let's go to IBM Cloud and I will show you how to set up the evaluation process. As an IBM business partner, you can easily reserve the watsonx.ai and .governance resource from TechZone. After you have the watsonx, you will create a project, and within the project, we'll create a new asset, which will use the prompt lab to build a prompt template. And here we use a sample prompt, for example, this sentiment classification, and we will this predefined instruction is classifying the review as positive or negative. Here is the input. Now we can have quick testing generate. The output is positive, which is the expected format for our testing. To evaluate this, we need to create a prompt variable. So we'll do it here, call it input. The default value will just give a dummy value, for example, great experience. And for this input review, we'll just use this input variable we just created. Let's have one more testing. Looks good. Then here we will select the model we want to evaluate. We will start with this 3 billion model, which is smallest in watsonx.ai. Then we'll go to the evaluate process. By clicking this icon, we will go through the saving prompt template first, give a name. The task will go classification, then save. After we save the prompt template, we'll go through the evaluate setup. So the first step is to select the dimensions, which mean the metrics we'll use. Since this task is classification task, it automatically select this standard accuracy metrics. The next will be upload your testing file. The testing file is a CSV file with two columns. The first one will just the input column. The second column will be the reference label data. So I already have 100 testing data. I just upload that. After the data is uploaded, we need to define which column is the input data, which column will be our reference output. The next, we just review the evaluation task and click evaluate. Now the watsonx governance will starting to evaluation based on the testing data we provided. It may take a few minutes. Let's jump into this evaluation report. So here is a report I did earlier today. It will show some high-level information. Here show the test is passed because all the metrics is past the threshold, and also some model healthy data. For example, the latency as a medium record latency, the token, all total token consumed. Then here is the detail for all the metrics. For example, the accuracy here is 97%. which means the model have 97 correct classification out of 100, which is very high accuracy. And I repeat this process for 3 times with different foundation models. We can, after we do that, we can also to compare this model. For example, this model is a 3 billion model, and I want to compare with our larger model, for example, the 11 billion model. There will give you a side-by-side view on all these metrics between these two models. After I repeat this process for 3 times, then I create this table to comparison. We can see here the 3 billion model is much cheaper, is 3 times cheaper than 11 billion model, nearly 9 times cheaper than 20 billion model, based on the SaaS price on IBM. And also the latency 3 billion model is relatively fast. The accuracy here, 97, although it's not good as 98, but 0.97 is already very high performance. So in this simple sentiment analysis task, 3 billion model does give us a cheaper, faster, and better options. Then if we go to the second testing, where we summarize the news like this to a few sentence summary, I testing them on the same 3 models, but use a different metrics. This metrics is only is used for natural language processing task, which basically to compare how similar between the reference summary and this model generated summary. If this value is higher, then means it's more similar. So we can see here the 20 billion model gave the best performance, or gave the most similar summary compared to the reference summary. I think which is expected, consider the 20 billion model is more complex for this complex task. Interestingly, if we compare 3 billion model and 11 billion model, we can see the 3 billion model does give a better performance than 11 billion model. I think there is another point to see larger model or bigger model doesn't guarantee a better performance. Besides these two testing, the IBM technology also shared a great video called "How Large is Large Enough?" Within the video, the IBMers share the testing they did and find the smaller model is cheaper to train and also is faster to run. For the accuracy perspective, they do this testing on financial data across different tasks like entity extraction, summarization, classification. The small model achieved a 0.57 score. The larger model achieved 0.59 score. So consider the significant difference on this latency and cost. I think the performance accuracy is relatively similar. So in conclusion, the smaller model does give us faster, cheaper, and better performance on some use case. And watsonx.governance can help you easily to evaluate different foundation models on your use case, so you can find the right model